do a little bit algebraically. Oh, did somebody just pop in? Hang on a sec. Oh, something happened. Weird. All right, well, I guess it's all of us. Okay. All right. So same thing with this one. I don't know where my recording went, but it's recording. We're going to determine the area bounded by the curve. So this is a straight line. So we're going to graph that, which I think we've already done a couple of times. Oh, that's not working. There we go. Crosses at 2, and my slope is 1. So it's going to look something like this, and that'll be my line. Now this is saying it is bounded by, so it's not giving us the actually it is bounded by the x-axis. I don't know why that's jumping around. -2 to +2. So from here to here, and the x-axis. So we're looking at this triangle here. So the base of this triangle will be 4. Well, I got to reorientate. Sorry. If you guys can calculate the area of that triangle, which I'm sure you can, has a base of 4, has a height of 4. Hopefully that works a little bit better. Yes. Okay, so area 4 times 4 divided by 2. So I have an area of 8 units squared, just because I don't know what they are. Okay, now part B says solve it algebraically. So algebraically is going to be using the integral. So part B, we're using the music symbol. Upper limit is +2, lower limit is -2. So upper limit on top, lower limit on bottom. My function is x plus 2, and that we derived it in respect to x. So step 1, do the antiderivative. So we're going to have x squared over 2 plus 2x. That has to be in square brackets, +2, -2. So we're going to have to evaluate it. So I'm just going to move over here. So I'm going to put my +2 in first. So I'm going to have 4 over 2 plus 4. Subtract 4 over 2 minus 4. So this one will be 6 minus a -2. So my area will be 8 units squared. Okay, easy peasy. That's I3. You guys have done that, no problem before. Okay. Hang on a sec. I just got to close my door. Hi, I'm just teaching right now. Okay. I don't want blinds though, because I made my curtain. I prefer not to have them. Okay. Okay. All right, guys. So did yours say x squared? Because it should say x squared. It should say 2x squared plus 1. 2x squared plus 1. Did yours say that? Okay, cool. Mine's just messed up. All right, so parabola. If I'm looking at this, I know my vertex is at 0 and positive. What do I do in here? 0 and positive 1. So that'll be here. And if I do my pattern, 1 away, 2 up, 1 away, 2 up, 2 away, and that's going to be 8 up, which is way too much. Oh, let's see if I can do this. There we go. All right, there it is. So this one says that my function this is bounded by the x-axis. So what it's telling you is it's stopping at the x-axis for area. And it's bounded by the interval -1 to +1. So really what I've got here is this area under the curve. So this whole green space right here. So that whole green space right there. All right, so this one, as you can see, is going to be much harder to calculate graphically because it's not nice. It's not linear. It's not going to give me a triangle. It's not going to give me a rectangle. So I have to rely just on my integration. So I would integrate or use the integral of 2x squared plus 1 derived in respect to x, that's what a dx, and my boundary is 1, -1. Okay, so first thing I'm going to do is anti-derive that. So I'm going to have 2x cubed over 3 plus x. And that's going to be bounded by 1 and -1. So then we're going to just evaluate. I'm just going to extend my page. So 1 in first. So 2 times 1 cubed over 3 plus 1 minus, that one's going to be 2 times -1 cubed over 3 plus a -1. So if I've done my math correctly, this should be 5 over 3, and this will be subtract a -5 over 3, which should give me positive 10 over 3 units squared. So again, like even though I have the picture, I've got to make sure that it's like sometimes I can't do this one graphically. That's what I'm trying to say. Sorry, somebody's texting me. Don't these people know we're learning? Okay, so pretty easy. Again, this is just all I3. It's going to get a little bit more exciting on the bottom of page 2. All right, so the area bounded by this function is going to be, so my vertex is going to be at 0, -3. X-intercepts are going to be at +1 and -1. So it's going to be a really skinny graph. And I'm assuming that all of you are confident in graphing a parabola. Okay, so this says determine the area bounded by the function and the x-axis. So that would be, for the very first time, we're now inside the curve. We're inside and under the x-axis. So we should anticipate that the area under the x-axis is going to be negative. If I don't get a negative answer, there's going to be a problem. So we're going to, again, the only way I can do this is anti-derive it. So the integral of, now my boundaries, although they might not be obvious to you, they might not be obvious to you, it's where that function hits the x-axis. So it just so happens that it's nice at 1 and at -1, and it would be 3x squared minus 3 differentiated in respects to x. So anti-derive that, I'm going to have x cubed minus 3x. Now I skipped a step, and I'm hoping that you guys are okay with that, because when it would have a coefficient of 3 and a denominator of 3, so those just end up canceling each other out. So I just didn't put that in there. So I'm going to have 1 cubed minus 3 times +1 minus -1 cubed minus 3 times -1. So I'm going to have -2 plus, no, that's a minus, sorry. Subtract a positive 2. And that's going to give me a negative 4. Units squared. So we anticipated it was negative. It is negative. Life's good. So again, this is just all I3. This is just a repeat of I3. This is the next part, this little part on the bottom here, is the area bounded by a negative function. So that's just below the x-axis and is closed on the interval. So this is a closed function because it's bounded by, it's inside that function. It fills it up. It's bounded, it's closed, because if it was on the outside, it would be infinite. It would go on forever. I'm touching the board and you guys can't see it. So if it wasn't closed, it would be all out here, and that would be infinite, and that would be pointless to try to calculate. So here's the deal. This is what they're saying. This is what I'm saying. This is what they're saying. So if you expect it to be below the x-axis, all they're saying is treat it as an absolute value. Because you know how on, I think it was on I3 assignment, and you got an area of 0. We don't want that to happen because really there is an area. So what they're saying is that one below the x-axis, just make it positive. We're going to negate it. We're going to treat it like it's an absolute value. So that's nice and easy. All right, page 3. Things get serious. All right, cubic function. So we're going to do it algebraically, and then we're going to do it graphically. Yick. No, we're going to graph the thing. Okay, so let's look at this. We're going to determine it. We're going to do this like it's I3. We're going to do it like it's I3. So part A, I'm taking the integral of, what was my integral? X cubed minus 4x, and it gave us a boundary of 2 and negative 2. So it's just giving us something to work with. And that was differentiated in respect to dx. So this is going to be x to the exponent 4 over 4 minus 4x squared divided by 2, bounded by 2, and negative 2. All right, so if I do this, I'm going to have 2 to the exponent 4 over 4 minus 2 times 2 to the exponent 2. Are you guys okay that I just changed that to a 2? Yes, of course you are. You're very smart people. So that's going to give me negative 4 minus a negative 4, which will have an area of 0. Well, that's sad. That's sad. Okay, so areas of 0, but we know that there's going to be an area under the curve. So let's go ahead and do part B, which is solving it graphically. So sketch the graph of f of x, including relative maxima and minima. The on the end is just plural. It's just a way to say all of them. Okay, so now let's do our x-intercepts. So part B, x-intercept. So our graph was x cubed minus 4x equals 0. So if I common factor out an x, I'm left with x squared minus 4. So I know I have x-intercepts at 0, 2, and negative 2, because that is a difference of squares. Did you guys need to see that all the way out, or are you good? Okay, you're good. Y-intercept for this one, the y-intercept, if I substitute 0 in for x, my y-intercept is going to be 0. So y-intercept is equal to 0. I don't know what's happening here. Things are bouncing around. I'm going to move. All right. So here's the relative maxima and minima. End behavior for this one. This would it's a positive cubic function, so it's going to start in 1 and end in quadrant 3. And so now to find my max and min of my graph, I'm just going to move over to the left-hand side just because my thing keeps bouncing around. I'm going to take the first derivative of that cubic function. So that's going to give me 3x squared minus 4. And if I set that equal to 0, you're going to have to believe me. Oh, I guess I could do it this way. I could have 4/3 equals x squared, square root both sides. So you're going to have plus and minus the square root of 4/3 equals x. So that's going to be plus minus 1.15. 1.15. So if I put that on a number line, I got a negative 1.15 and a positive 1.15. That's a lot of ones and a lot of decimals. I'm going to substitute values in. So something less than negative 1.5. I'm substituting, let's say, negative 2 in. That would be 12. 12 minus 4 is a positive 8. If I throw a 0 in, because that's in between them, if I put 0 in, we know that it will be negative 4, so this one would be negative. And if we put 2 in, it's still going to give me a positive. So we know that this one will be, the first one, the negative 1.5, is going to be a max because it's going up, 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 and then it's going down, down, down. And then we're going to go down, 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 and then we're going to go back up. So we know that this one is a min. I could have used my second derivative to prove both of them, but a number line was just as fast in this case. All right, so here's the thing. We're going to graph it now. So my x-intercepts were at 0, 2, and negative 2. My y-intercept was also at 0, so that's handy. And I had maximum, I forgot to find my coordinates. So 1.15, and I know you all trust my math, is 308, 3.08. And the positive one is negative 3.08. I know you all trust my math. So I would have had to substitute this value back into the original cubic function to get that. So at negative 1.15, I'm going to be about here. And at positive 1.15, I'm going to be about there. So start in 1, end in 3. So it said the area bounded by the function and the x-axis. So if we do that, and as you can see, it's symmetrical. So, the x-axis, the function bounded by negative 2 to positive 2. So that's this area in here, all the way to the x-axis. And then there's this one below. And what if we jump back to our red math? I know I'm going quick. If we jump back to our red math, I know it's symmetrical because both these areas are the same thing. So what it's saying is take the area, negate the negative, and let's go from there. So if we were to negate the negative, we would know that this has an area of how much? What's the area of this section? Well, the total area is 0 if we're treating one as positive and one as negative, right? But drop the negatives on it. So what's the area of the upper one? It's It's got to be 4 because both of them are 4. Both of them are -4, but we're dropping the negatives. So it would be 4 here. What did I mean, Nihal? Okay. And this one has an area also of 4. Now, it's below the x-axis, so we always would say it was a -4, but really what we're looking for is the area. So we're going to treat it almost like an absolute value. So what would be the total area of this picture here? What would be this? Be 8. Exactly. So that's what we're doing moving ahead, is we're going to treat it as an absolute value. Forget that negative areas occur under the curve. So this is what I'm going to show you, the next. So now in I4, I'm giving you a completely different, well, it's not a completely different formula, it's an edited formula. So on page 4, what it's saying is take your first interval, add it to the absolute value of your second interval. Now, assuming that this is the one that is right? So that's all they're doing. Regardless of the sign, the area bounded by f of x and the x-axis is defined by the absolute value of the function. So the total area, we're going to treat it as an absolute value. So that's the difference between I3 and I4. In I3, just learning how to use integrals, you can get an area of 0. In I4, I want you to be more mindful that we're going to use things as absolute values. So you're going to have that plus. You're not going to have to worry about making it a negative. And that's it. That's all. Easy peasy. Yay. So I know I've got a bunch of you here before you just... Did Thomas leave already? I can never catch that kid. So we're going to have our quiz on Monday. On Monday. What time do you guys want it? 1:30 or 1? Okay, I'll throw it. How about this? I'll throw it out at 1, and you can have it back to me by 4.